Hello friends, welcome to G-Centric. So in this lecture, what we will see is the interconnection of two-port networks. That means till now whatever we have seen only with the circuit of one-port network. Just one circuit of the two-port network. Okay, so here interconnection means there will be like two circuits of two-port given. Okay, where we can connect those two circuits either in series connection, which we will solve it by impedance parameter, or parallel connection will be there, which can be solved by admittance parameter. Okay, similarly cascade or tandem, which we will call it as ABCD parameter. So this type of cascading can be solved only with ABCD parameter. So coming to series and parallel, if the one side of the port has got the series connection and the second port has got the parallel connection, then we will use the hybrid parameter to solve these type of questions. Okay, coming to fifth one, this is parallel and series. Similarly, on the right hand side, if we have got parallel connection between the ports, okay, or between the lines of the ports, and secondary we have got like series, right? So that time we will use G parameter to solve the question. Okay, so now coming to this, after learning this, we will see one by one, okay, in which first three are very important. Okay, so these are the three things which is important for the gate point of view. Just for these we will see only the circuit diagrams. We will not solve any questions for this series parallel or parallel series. Okay, so coming to the first one, series connection. How do you do it? Firstly, there is one two-port network circuit, that is A, which we will name it as A, and the second one we will name it as B. So both the sides, both the ends will be having the series connection. Okay, so now if I take here, this is port A, okay, which has got two ports. Okay, similarly we will take another circuit named B. Okay, so this is the second circuit. So now we will do it still more extended. Okay, so what in series we know that, in series connection we know that current will be same. What varies in series? It's nothing but the voltage. Okay, so voltage is varied. Okay, so here to make the same current flow in both this network A and B, what we have to do is join these two parameters. Okay, so this will be V1, as usual that we write it as V1, and here it is V2 network. Okay, so this is the V2 voltage, V1 voltage, and here current I1, and over here current I2. So now in this what I have said is that current will be same. Coming to the voltage, this V1 will be divided over here, right? So this we can name it as V1A across the A circuit, and this as V1B across the B circuit. Okay, so similarly here I1 means here also I1 current will be flowing, right? Here I1B current will be flowing. So this current, similarly we can write over this side also, this as V2A voltage and this as V2B voltage, and here I2A current and this is I2B current. Okay, so what is same? I1 will be equal to I1A equal to I1B. Similarly I2 will be also equal to I2A and I2B. But what is varying? V1 and V2. So V1 will be equal to sum of these two voltages, that is V1A plus V1B. Coming over here, V2 will be equal to V2A plus V2B, right? So it is becoming addition. Current is same. So when we divide this whole equation by current, so we will get Z parameter. So Z parameter will be nothing but ZA plus ZB. Okay, so impedance will be ZA plus ZB parameter, right? So this is what we have to do. So now coming to that question 225, if you see here, both these look the same, right? Over here it is connected and here also we have a connection. And to find the Z parameter, we know that we have to use the T T network. If it's not given in the T network, this is given in the pi network. So we have to convert that to T network and then solve for the Z parameter. Okay, so coming to this question, using this theory, we will solve this one. So we have here V1 current, V2 current, and this is in T network, right? So ZA we will get it as, directly we can write. So this will be 2 plus 4. We'll get Z11, okay? Then 4 plus 4 is Z22. And these two we have to fill as this one, right? So this will be 4. Now to solve the ZB, okay? So to solve the ZB, first we have to convert this one to T network. So it's nothing but this is in the form of delta. We have to convert it in the form of star network. So I can do it like this, right? So to get the value of this one, I have to multiply this and add some of the resistances. 6 into 3 is 18. 6 plus 3, 9. 9 plus 1 is 10. So this is 18 by 10. Similarly, this will be 6 by 10 and this will be 3 by 10 ohms, right? So this is also converted to T network. Okay, so what to get the Z11 parameter of this B parameter, ZB parameter, we have to add this one. 18 plus 3, 21 by 10. Similarly, this one to get the Z22 parameter, 6 plus 3 is 9. 9 by 10 ohms. Okay, and here this will be Z12 and Z21 will be 3 by 10 ohm, right? So now our Z parameter, how to find out? ZA plus ZB. Okay, so and when we add this one, we will get the Z parameter. So what is it? 6 plus 21 by 10. So 10 into 6 is 60. 60 plus 21 is 81. 81 over 10 is 8.1. Okay, similarly 40, 43, that is 4.3. This is Z12 parameter. Coming to Z21, it will be again 4.3. Here it is 80, 89, 8.9. So this is the impedance parameter required to solve for this question. Okay, so this is series and this second terminal is open, okay, in this second line. So this will be having, here we will be having V1A voltage and here V1B voltage. Similarly V2A and V2B voltage. Okay, so this is about the series connection which we have solved using the impedance parameter. Coming to the parallel connection, what we will use admittance parameter to solve the question. Okay, coming to this second type of connection, that is parallel connection. Okay, so now we have got two networks again. Let us take circuit A and circuit B. Okay, so this is A and this is B, which has got two terminals over here and two terminals over here. Okay, so now in parallel, what will be same? Voltage is same and current varies, right? So we have to maintain this voltage similar across both the terminals. So what we have to do is connect this first terminal with the first terminal of the two-port network. Okay, so next similarly with the second terminal, and this will be our V1 and here current will be I1. Same thing we will do over here also, first and first. Okay, so first terminal, then we have got second terminal and this is V2 and this is current I2, right? So now in this case I1 is varying, so here there will be different current IA1 and here it will be different current I1B. So here also same thing, I2A and here it will be I2B. See over here, if you come over here, this will be divided. Okay, so this current is divided, whereas in the previous case the current was same in both the branches. Right, so now this is V1, this V1 and this V1 will be same. So for the admittance, if we have to calculate, then it is YA plus YB. So individually we have to solve the admittance parameter of two-port network A and two-port network B. Then we have to add them to get this admittance parameter. So this question is related to this one. So if you see over here, this type of question is nothing but the parallel connection. Over this side also it is parallelly connected and over this side also it is parallelly connected. Okay, so now we have to find Y parameter. So basically Y parameter supports the pi network. Okay, so when it supports the pi network, we have to find in the circuit pi network, right? So this is the pi network, but now here we have got T network. So easily this can be converted. This is in the form of star, so we need to convert it in the form of delta, right? So over here this will be converted into delta. To get this one, what we have to do, 2 plus 8, 10, okay, then multiply these two, 8 2s are 16, divided by whichever is left out, 4, okay, so 4 plus 4 is 14, so this will be 14 ohms. Coming over here, so 4 plus 2 is 8, sorry, 4 plus 2 is 6, 6 plus 8 by 8, 1, that is, this is 7 ohms, okay, 8 plus 4 is 12, 12 plus 32 divided by 2, 16, right? So this will come out to be 28 ohms. So now if you see here, this circuit, this pi and this pi is same values with the same resistors also, okay, for the arms. So directly we can write this Y as YA plus YB. So if you find out one thing, same thing will be for the other. So we will find out YA. Now here what is the twist is, for calculating the admittance, you have to take 1 over for everything, right? Whatever value you have got, right? So now to calculate Y11, this is same thing, 1 by 7 plus 1 by 14. Similarly for Y22, 1 by 14 plus 1 by 28, and this will be negative of this whole thing, that is 1 by 14 minus 1 by 14. Same thing, this will be YB is equal to YA. So write this one, this matrix over here, then add it, you will get the Y matrix. So now we will see the third type of connection, that is cascade connection. Okay, so now I'll just rub this one over here so that it will be easier to calculate, since we will not solve the cascade or the tandem question based on that question. Okay, it's just nothing but we'll take it. Cascading is like you have seen in the control system. Okay, cascading is you will multiply both the parameters, right? Similarly here also we will do the same thing. So third connection is nothing but what we have, cascade or tandem, that is using ABCD parameter, right? So if you take connection of see, if you have learned the control system, this is a gain blocks. So if two things are cascaded in this way, then you will multiply, right? It will be G1 into G2. Similarly in the network, if you have got one port over here and another port here, what you will do is nothing but join the networks in this way. Okay, so this will be V1 and this will be I1, this will be I2 and this is V2. Okay, so for this there will be different voltage also, this will be also different, but when you cascade it will be T equal to T1 or TA into TB, right? So individually you have to calculate the value of TA, okay, ABCD parameter of B, then multiply it. So this is about the cascade or tandem connection, which we can use only by using the ABCD parameter. Okay, so next coming to the fourth one, which is not so important, that is series to parallel, right? Series parallel connection. Same thing we'll take, we have here A and we have here B. So if it is series, then it is these arms will be seriously connected. Then the second arm over this side, this terminal, it will be parallelly connected. So first port, then this is also second port and second port. Here current will be same and here voltage will be same, right? Okay, so this also using H parameter you will solve it. So HA plus HB. So here only I will show you next parallel to series connection. So parallel it will be same, but over here, so this is fifth parameter, series. Okay, so here we have got in this way, and this will be, voltage will be different over here. So this is parallel and series connection. This terminal will be connected in parallel and this will be connected in series. So this can be solved using G parameter, GA plus GB. Okay, so for our gate syllabus only first 3 are important. Okay, so next, in the next lecture we will see the combination of these networks. Okay, we will use all these parameters to find different parameters, right? So if we have Z parameter, how we have seen in already in the previous lecture how to find its inverse. So when we find the inverse of the Z parameter, we will get admittance. So similarly, we will take one question and we will solve almost all of the parameters for that question. Okay, see you in the next lecture. Thank you.